All right, guys, Unit 1 is done. We're moving on to Unit 2. So what you're going to find as we kind of go through each unit in algebra is it's very similar to the one before. They just add an additional layer. Um, and so, once we get to Unit 4, Unit 5, we'll have done a lot of the same things and just applied different terminology or written things in a little different format than what we're used to. Today we start off with kind of defining some new terms for us, and then exploring very briefly one of the concepts, and then we'll push further in the unit as the videos go along. Okay, so Unit 2. Okay, what's it all about? Um, Unit 2 is relations and functions. Okay. Um, a small part of the unit is going to focus on relations, and then the remainder is all about functions. So, real briefly, we'll talk about relations and some different ways that they're represented and some ways that you have actually seen them in the past. Okay. Um, and so, first, we'll start with the definition of a relation. And it's very simply a set of ordered pairs. So it's just a fancy way of them saying a set of ordered pairs. Um, and so ordered pairs are very familiar to us, as we all know, right? Ordered pairs are X first and then Y, every time, always in that order. Um, and so as we talk about the ordered pairs, you'll know that we have a set of X's and a set of Y's, and we can list them in a couple different ways. So, example 1, right? Uh, so we'll have our list first. Okay, so this would be the first way you might see them in no particular order. We've got -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. Okay, close that out. All right, so this would just be our a list. Okay, that's what we would just call a list. They're just listed out, no particular order, just in a list. All right. Now, the next way we're going to write them out, you'll recognize as you did these in 6th grade, and that is via table. All right. So we have an input-output table. Um, is how we might represent a relation. Okay, so your X's are in one column, your Y's are in the other. Typically, these are ran in a least to greatest format, but it's not necessarily um, required to be that way. We've got one more there. That's going to be -3 as well. So 1, 0, 2, -4, 5. All right, so input output table. And so if you'll remember, right, the X is where your input, the Y is where your output. And that was, 6th grade. We would use these tables to define our ordered pairs, and you can see they're just matched up with their corresponding output and input. as if they were written from the parentheses above. Okay. And so we also could represent these as what is called a mapping. And so this one's kind of new to us. It's a mapping, okay? And a mapping is simply going to be either two circles or two rectangles listing, right, X and Y's. So we've got X here and Y here. Now, the difference in a mapping is you don't simply write them across from each other. You would write them least to greatest. And you would only write each number one time. So whether it appears more than once or not, we're only going to write it one time. The -4 should have gone up top. So let's see. That's 2. That's a 1. That's a 0. And then this should be -4. All right. Okay. So our mappings are going to go least to greatest from top to bottom. And then we're just simply going to draw an arrow or a line to match it up with its partner. So the 2 does go straight across there to the 0. Then the -3 goes to the 1. The 1 goes to the 2. The 3 to the -4. And then this -3 goes down to the 5. Okay. So that's a mapping. You can see each line is connecting one X to its corresponding Y. In the case of -3, you'll notice it's got 2 lines coming from it. So this -3 could go with the 1. This -3 could also go with the 5. Okay. So if we were trying to convert a mapping into ordered pairs, for each line, we'd have one end being an X and the other side being the Y. Okay, so that's -2, 0 in the ordered pair. -3, 1, -3, 5, and so on and so forth. Okay. And lastly, I'm not going to draw it out right now just because for space constraints and also because I know you guys have seen this before. You would have a graphical representation, and that's simply plotting the points. Each one of these is a point on a graph. Okay, you have your X, Y coordinate grid system, and we would simply plot those points and be able to, whether we're going from an ordered pair to a graph, draw the point, or if they give us a graph of points, we would be able to then write the ordered pairs from that. So just case in point, I do have a example here for you that we could look at. So if you had this graph, you'll notice, right, there are no numbers. It's not written out, but we could go to this graph and look at it and pull off each set. So that is 4 and 2. So one of our ordered pairs would be 4, 2. The next one would be 2, -5. So that would be another ordered pair. And we could continue until we had all dots. So you could put an X as you get that dot, so you know that you've got them. Make sure you get them all. Count them. Make sure you've got that many ordered pairs written down. And so you could simply go from no numbers to now I have numbers. I pulled that information from the graph. So that's a relation, guys. It's just a representation of a set of ordered pairs. So lots of different ways that you could go about representing them. The newest one for us is a mapping. And just remember, it's an X connected with its Y. So you could take that straight into a list or an input-output table or even a graph. Although I wouldn't suggest going straight from a mapping to a graph. I would make the list first and then plot those points. Okay. The big part of this unit is going to come in the form of functions. Okay. So we're not going to get into evaluating functions or any graphs or anything like that today. We're just going to define it and then look at how do you know yes or no from one of these examples, a table, a mapping, a list, or even later we'll look at graphs. How do you know if it's a function or not? Okay, so function. Now, the way I describe it to my students in the past, when you're trying to determine a function, and we'll define it mathematically or academically here in a second. Basically, a function, if you think about it, it's a form of work, right? When something functions, it does work. So if, right, an equation or a relation or a list of ordered pairs or anything, if it is to be defined as a function, it will do work, okay? And by that, I mean it's going to give you a very specific answer. So we'll define it and then we'll kind of explain through examples what I mean by it'll do work. So it is a special relationship between values, each input, which we defined as X, has exactly, right? Exactly one output. And that was defined as our Y value. Okay, each input has exactly one output. And so here's what I mean. Okay, a function, okay, will do work for you in that if you think of it in a business sense, okay, if your boss came to you and maybe you're selling snow cones and he comes to you and he says, well, if I sell 3 snow cones, how much money will I make? Okay. A function would tell you that. A function is something like an equation, and it would tell you, well, based on my calculations, maybe you sell them for $1 a piece, you would make, $3. Okay. So that would look something like, right, 3x, right, would answer his question. Okay. So in this regard, very simply put, right, very, very elementary. In nature, this would be a function, right? This would start to define what a function is because it has exactly one answer. Meaning if I have an input, right, X, and he says, hey, we have, we're selling them now for $2 a piece. 3 snow cones is going to give me how much? You would say 6, right? Because 2 times 3 is 6. But if for some reason your equation was much more complex in nature and your boss came to you and said, well, if I sell 3 snow cones, how much money would I make? And you said, well, there is a case where you could make $6, but there's also a case where you could only make 2. Well, now you have 2 outputs for only 1 input. So the 3 snow cones, right, are yielding 2 different answers from the employee. And that doesn't work, right? Nobody wants to hear that. They want to hear certainty. So just, in a very, very elementary, right, very simple sense, a function is going to give you an exact answer for an exact input. Now, as we go along, you'll see that you could end up getting the same answer with different values going in. It's just possible mathematically at times, but you're getting for each input, you'll get something specific out. Meaning, like I said, if you sell 3 snow cones, there's not 2 different possibilities on your profit. There's only one. And so a function would govern that situation. So as we look at different examples here, and again, we're going a very basic approach to begin with, and we'll start to progress into more and more complex ideas as we move into the unit. But so I'm going to go ahead and nix that example so that we can kind of move into real examples, right? So example 1 for functions, right? And we're really going to just do 2, and one is a function, one is not, and just realize that why it's not, okay? So we've got, let's just go with, yeah, let's do a list first, okay? So 0, 6. 5, -2. We'll just do it like this, 7, 9, and 11, -1. Okay. So is it a function? Okay. And that's the question, right? Because it doesn't have exactly one output for each input. Well, the important part here is that we don't see the same input used twice in a row. So 0 yields a 6, 5 yields a -2, 7 yields a 9, and 11 yields a -1. Now, what the equation is, we're nowhere near that yet. As far as algebra goes, we're not worried about that yet. What we're worried about is determining, right, whether or not this could represent a function. And so as I look at this one, right, I don't see any of the x values being repeated, and therefore in this discrete, okay, this is what we would call a discrete set because it's these 4 and only these 4 points that we're concerned about. We make no assumptions about additional points in between or outside of the range we're given. So these 4 discrete points, there are no repeating inputs, and therefore each input here has one output, right? You don't have a 0 and then 2 potential y values. So yes, right, this is a function. And so I can tell that because, right, there are no repeated x's, no repeat x's. That tells me that is a function, all right? However, right, let's go to another quick example here of another set of ordered pairs. So 4, -4, 1, -1, 7, 5, 6, and -1, -2. Okay, we'll close them all in so it looks nice and neat and organized, and close it all off as a set. Okay, so in looking at this list, right, this is another discrete list for discrete points on a graph or inputs and outputs. So we can look at each input to make sure it corresponds with only one output. And so we have -4, -1, 5, and -1. So this right here is a problem. This right here tells me that whatever the equation is that is governing these points as they are established, right? When I put a -1 in there, I might get a 7 or I might get a -2. That's an uncertainty. And therefore, right, this is not working. This is not going to do a good job at governing some situation. So this would be a no, right? Highlighting again that we have two repeating x values, all right? And that's a big deal in this unit. You cannot have functionality if you repeat x's. So one more example, and this is just going to be a mapping for us. Okay, so very short list of terms. So there's a mapping and there's a mapping. We'll do two mappings. So we have an x and a y here. So -4, -1, -2, and 1. And then we have -1, 3, 4, and 7. All right. And so according to the mapping, we have -4 to the 4, -1 to the -1, 2, -1 also goes to the 7. Okay. 1 to the 7. And then we have -2 to the 3. Okay. So if we look at our mapping here, you can see that each one of these is going to correspond to a ordered pair. So we technically have 1, 2, 3, 4, 5 lines. So that means we should have 5 ordered pairs if we were to make a list or graph them out or make a table. But what we're looking at is, do we have any repeat inputs, repeat x values, right? Because again, if that repeats, then we have a problem. We have this mix up in outputs. So -4 only goes to a 4, but if you'll notice this input of -1, okay, it could yield a -1 or it could yield, right, a 7. And so that in that case, right, I've got a no. This is not a function. We've got a double, right, a double input happening. And that's not allowed. Okay, so we'll look at one more, and then we'll call it a day. We'll only fit so much information in one time. So draw out our mapping, and the reason I focus on mappings is that's really the newest form of what you've seen. So we want to make sure we look at plenty of examples there. All right, and then we've got 0, 4, 7. And so this one might be a little concerning before I draw the arrows, only because you see 4 numbers here and only 3 numbers here. And that's okay. So we've got -3, 0, -1 to a 4, okay, 2, going to come down to the 7, and then a 4 to a 4. Okay, and so you can look at this one, and if we were to make a list of ordered pairs, we would have 4, right? We have 4 times where it crosses, so we have 4 ordered pairs happening. Okay, and what you need to look for is for every input, is there an output? And there's no duplicate inputs. So the -3 isn't yielding 2 different numbers. So -3 gives me a 0, -1 gives me a 4, 2 gives me a 7, and 4 gives me a 4. Now, this, okay, this is okay. We're allowed to have the same output happening because these are unique inputs. So there are times, right, when certain things happen. If you think about, again, a business where you would have situations where you're tracking cost versus profit, and maybe the graph is kind of going up and down, right? Yeah. So there's a good number here where you want to stay, but then as maybe something increases, the profit goes down. And you can see there's points on this graph that have the same Y, they have the same elevation, but they are happening at different intervals. So we have different inputs creating outputs. So the inputs are all separated. You can see there's no doubles here. There's nothing coming off one number twice, where we did over here, right? We had the 2 coming off that -1. So this one is a yes, right? That is a function. Okay, well, so we're going to leave it there today. Again, pretty simple, but just remember, right? A relation is very simply a list of ordered pairs and can be represented numerous different ways. The focus is really the function and recognizing that we have one input creating an output. And that output could be all the same. Could not matter at all what the Y value is. It's all about that input. We can't repeat an input in a function. All right. Thanks, guys.